Okay, everybody, we're going to keep going with our work on lines and things about lines. So we've done stacks on lines and linear graphs so far. So what we're going to work on today is finding the midpoint or the length of a line, which can be really useful if you want to know something about a graph or a linear rule. So the midpoint is, like it sounds, the middle of the line. So the midpoint of a line segment, and that's just part of a line, is the halfway point between the two ends. And it's found using the following method. So if we're looking here, the x-coordinate is the average or the mean of the x-coordinates of the two ends. So the halfway point is the average of the two endpoints for the x's, and same with the y. The halfway point is the average of the two ends of the y's, and it can be written in this formula here. M, now notice that M is for midpoint here. It's a capital M, it's not a small m for gradient. The x-coordinate, so this will give us the x-coordinate of the midpoint, and this will give us the y-coordinate. It's found by adding the two end x-coordinates and dividing by 2, and similarly for y, adding the two end y-coordinates and dividing by 2. And there's a little picture here of a graph that's got that. So it's got a line segment drawn in it. We know it's a segment because there's no arrows on either end saying it's still going. But one end coordinate is a 1, one end coordinate is a, 1 and 5, and the second end coordinates are 4 and a 2. And you can see they're pulling out the x coordinates for here and the y coordinates for the second one. And you just add them together and you divide them by 2. And note they're done separately because you're going to get two separate numbers which become our new x and y coordinate. It's also really important to note that you don't actually need to plot the line to find the midpoint. So don't feel like you have to do that if it doesn't say. If it helps you, by all means, but you don't have to. So let's have a go. So find the midpoint, m, x, y, so that's just the coordinate of the line segment joining these points, -4 and -2 and 2 and 0. So as I stated, find each coordinate separately and do that using the formula. And remember, the formula is just the average of the two endpoints for each coordinate. So our x-coordinate is x1 plus x2 over 2. Now, our x's, x1, y1, x2, y2. Remember I said when we were finding gradient using that little formula, you could label your coordinates you were working with. There's no reason you can't do that here too if that helps you. So our x1 is -4, our x2 is 2, divided by 2. That's going to be -2 over 2, which is -1. Whoa, that vanished. Let's pop that back. Okay, so our y-coordinate is going to be y1 plus y2 over 2. And our first y-coordinate is -2. Our second y-coordinate is 0, divided by 2. So again, we've got -2 over 2, which is -1. So in this case, our midpoint is -1 and -1. That's going to become our coordinate in the middle. Now, it doesn't actually matter which point is your first point and which is your second. You'll end up with the same answer no matter how you do it, so don't be worried about that. So hopefully that's clear and there's no questions, but if there are, please see me in class. Now, the other thing we're going to work on today is this, the length of a line segment. So we saw on this graph up here that we've got a line segment that's in blue there and it's a certain distance long. If we were asked to find how long that is, something we can do to use that is to use Pythagoras' theorem, which we all know. And just a reminder that c squared equals a squared plus b squared is Pythagoras. So we did that earlier in the year, so remember that. That is going to help us find the distance between these 2 points, which is really the length of that line. So what we need to do that is to get ourselves a right angled triangle. So let's have a look at this. So when we're doing this, the line segment is going to become our hypotenuse, or the longest side of our right angled triangle, which means we need to know what, so that will be C. So we need to know what A and B is to be able to substitute that in and solve that. And we can do that by plotting this line and then working it out off our coordinates. So note it says, find the horizontal distance by subtracting the lower x coordinate from the upper x coordinate. So that's really important. So we don't actually even need to plot it to do this, but it may help you. And find the vertical distance by subtracting the lower y coordinate from the upper y coordinate. So let's have a look here at this example and see what they did. So horizontal distance, well, first of all, you can see they've actually drawn a triangle. So that's going to be A and B, for example, in our theorem. The horizontal distance is find the horizontal distance by subtracting the lower x coordinate from the upper x coordinate. Now, so you take, it's upper minus lower is what that's saying. So in this, or biggest minus smallest. So in this case, our biggest one, well, our x coordinates are -3 here. And our x coordinate here is -1. The biggest one of those is -1, because -1 is bigger than -3. So it's going to become -1 minus -3, which is of course the same as -1 plus 3, which is 2. So that becomes our A value, which we can substitute into our theorem. Our vertical distance is the same as that as well. So bigger minus smaller is what it's saying again. So our vertical distance, the biggest one is 5. Our biggest y value is 5, and our smallest y value is 2. So 5 minus 2 is 3. So that is going to become our B value in our right angle triangle. Once we've got A and B, substitute them in to find C. So exactly what we've done before, C equals A squared plus B squared, and then they've substituted this in. So this would be A and this would be B, substituted in and solved. So hopefully that makes sense to you, but let's have a go at doing an example for that. So find the length of the line segment joining this pair of points correct to 2 decimal places. Okay, so I am just going to plot that, although you don't actually need to find it, remember, but let's plot that anyway. So y, x, now we need to go out to -2 here, and we need to go down to -4 here, because our points are -2 and 0, and 0 and -4. So our line segment is between those 2 points. Now, so in this case, our values that we're working with are going to be along the axes, which is fine. So this is going to become our A. Now I've just drawn it off the axis so you can see it, but obviously it would really be on the axis. That's going to become our B, because this is the part of our triangle that is a right angle. Okay, so to find the difference between the 2 points, subtract. Subtract the coordinates. To find the vertical and horizontal lengths. Then find the hypotenuse. Find the hypotenuse. So let's go ahead and do that. Okay, so in this case, whoops, the horizontal, or A, we're going to call it A. You don't have to use A, you might just want to go with horizontal, but if A suits you, then do that. Now, it's the smallest value minus the biggest value minus the smallest value. So in this case, our x values are -2 and 0. Obviously 0 is bigger than -2, so that's what we're going to have. So 0 minus -2 is going to be same as 0 plus 2, which is 2. The vertical will be, in this case, same deal, biggest minus smallest. So our values here are 0 and -4. Again, 0 is bigger. So that means we're going to have 4 for that. So our A and our B are 2 and 4 respectively. Let's put that into Pythagoras' theorem and find the length of the line. So that's going to become 2 squared plus 4 squared, which equals 20. But we don't want C squared, we want C. So that is the square root of 20, which is going to be approximate, and make sure you actually round. And the question actually asks us to 2 decimal places anyway. So 2 decimal places is where we need to stop. So make sure you answer as it is. So exercise 4H is what you need to do. And then homework is watch perpendicular and parallel line screencast. All right, see you in class.